Thank you for being here this early morning. My name is Etienne Caron. I'm an Android developer from Montreal and newly minted entrepreneur of sorts. Today we're going to be looking at building a machine learning powered Android live streaming app. So like you can see, I struggled a little bit with the title, but hopefully everything will become clear. So my company, I mentioned I'm an entrepreneur, so my company is called Canastruc Consulting Services. It's a bit of a mouthful. We founded it in 2022 as a small company that just basically sold software development services. And we were pretty lucky. We got some pretty fun customers right off the bat. So this is one of our first big projects. It was a marketing project for Bell Canada. It was all around the Formula One Grand Prix in Montreal. And so what we built is a remote-controlled race car type game. So here you can see at the bottom of the screen, we had players the players were on site at the Grand Prix controlling these little cars on this racetrack in a studio somewhere in downtown Montreal. So this was all over WebRTC, super interesting project. We developed the phone software, the WebRTC client and service. We had developed these little prototypes of cars. We did business with a firm for the shells and everything else, and the maquette, of course, it's like a pretty big endeavor, so you imagine that we didn't take care of any of that. But yeah, all the software side of things, quite an interesting project. We had a little bit of machine learning, so it was a bit like the seed for what I'm talking about today. A bit of machine learning in there where we wanted to track like the cars on the racetrack and try to locate them and see who had pole position and all of that. And a little bit of machine learning with a digital twin, so pretty cool project all in all. We're very lucky to get that. And then our next customer is for a company you probably have heard of in the US, Instacart. So we got a contract working on their Caper carts. So as you can see, these are checkout counters in a shopping cart for your groceries. And for them, I think most of the mandate that we did for them was to explore how we could offload the produce recognition work from their specialized computer vision hardware they had on board in the carts to a cheaper Android tablet. So effectively taking a big machine learning model and turning it to TensorFlow. We were not the specialists with the machine learning part. We were more there to optimize everything, do the video capture, really fine tune the pipes so that we could make sure that inference would run quickly enough with the models we were being provided with, and that we could do that very snappily. Now, produce might seem like a bit of a silly thing, but if you think about any kind of checkout experience you have, the produce part is really the one with the most friction. And so even just being able to recognize that you had produce that was going into the cart, you could save like a few clicks on the user interface. And in that situation, that scales up really quickly, right? The gain becomes really important. So here's like a little diagram of some of the techniques we used. So some of the tricks were to do some background removal with OpenCV, and then to prepare the workload for the image classifier so you can kind of get a little bit of the feel of how that was built. Again, a little bit of the seed part of what we're talking about today, right? You can probably see the connections a little bit going on. So after our contract with Instacart was done, we decided to refocus our efforts from simply offering consulting services to being more of what we would like to call an innovation lab for hire. So, of course, innovation lab, that's a really broad term. So our focus is really helping startups, small, medium businesses. And the idea we had is that we'd set ourselves apart by effectively just using cutting edge technology and applying it in innovative ways to solve real world problems, right? But not necessarily to reinvent the wheel, right? We're not like a think tank of doctorates doing new machine learning work, but we see what's in the space and we figured there's a lot to do there. So we wanted to be able to bring that to customers that don't necessarily have the budget or the expertise to do that kind of work. And so, as part of the onboarding flow of things, we really like to think about design thinking. We like to look at design thinking and sit down with the customer and sort of evaluate what they need. And if you're familiar with design thinking, it involves basically 5 stages. You got empathy, you try to empathize with your user's needs, then you need to define what those needs are and really like get into the nitty-gritty. Then you go through an ideation phase where you sort of think broad, how can we solve these problems? and then you start to focus back again in the prototyping stage. And so when you sort of boil it down a little bit more and get closer to the technical side of things, which is really where I'm at in the company, then you sort of focus on these three areas right there, and you cycle and you repeat. So you empathize, you think about the ideas, you prototype them, and as I mentioned, I'm the technical guy. I'm more of a technical founder is what I give myself as a title. And obviously I focus on the prototyping part. That's really what interests me in my first area of expertise. So as you can maybe guess by now, I've done a few things with WebRTC. And one thing that struck me with WebRTC is the potential there is really awesome. If you're aware of the technology, it's what's powering all the video calls that we have pretty much every day nowadays. It's what was behind Google's Stadia efforts. And it's used in a lot of different little circumstances. Now, the thing with WebRTC is it's pretty hard. It's been historically pretty hard to actually make applications with it. And that's changed recently. And after the Bell project, I realized, I learned about this company that was relatively new at the time called LifeKit. So what's nice about LifeKit is they make a fully open source series of tools and servers and clients. So they're the full stack open source solution for WebRTC. And they actually offer quite a little bit more, as we'll see in a minute. So the first thing you get out of the LifeKit is a top-of-the-line server implementation for WebRTC. It has all the server code and all the tooling you need to run it with no strings attached. I think that's kind of important to say, because sometimes those open source companies, they're a little bit, they've got commercial interests, obviously, right? Somebody has to make money. But in this case, it's quite easy to self-host, self-install, and do everything on your own. Their services are really complementary to the open source platform. So there's not really any vendor lock-in. I just want to make that very, very clear, as we'll see, anyway, I think, in a few minutes. All right, so you might be wondering at this point, that's cool. So what does this all have really to do with an innovation lab? Why specifically are you focused on that? So my original epiphany happened when I saw this voice assistant demo that predates the ChatGPT demo that, by the way, nowadays is running off of LifeKit. If you look at the website, you'll find that out. So when I saw that first demo that was pre-ChatGPT 4.0 and all of that, I realized, there's a lot that we can do to sort of try new ideas if we just get different participants in a call. Now, today we're not going to look at making our own voice-powered chatbot. That's not the goal at all. If you want to do that, though, everything is there. The code and everything, they explain it quite well. You can do those labs and build your own, and it's quite efficient and works quite nicely, and it's something you can do, I believe, in under an hour, frankly. Now, the reason we're not going to be doing this is because chatbots are not necessarily the best prototyping tool out there. They're really useful. Obviously, there's a reason there's such a rage. But if you think about it, there's a problem with affordances with chatbots. If you have a nicely designed app and you're trying to optimize a workflow, you're going to end up with some sort of form, some button, a sequence of events that limit your choices. Whereas if you're working with a chatbot, we're effectively throwing a dictionary at you, and that's your affordance, effectively. Anyway, there's a nice rant on this kind of stuff right there. I invite you to check it out. But what we'll do now is we'll focus a little bit more on setting up a LifeKit server, seeing how we can use it to prototype innovative solutions, and go from there. All right. So before I dive into more code and more serious technical bits, I need to tell you about 3 core primitives that come back in LifeKit that will help you understand the whole system if you explore it a bit more. So you have 3 concepts. A room seems pretty straightforward, but that represents a LifeKit session. So if you think of a room, it's where people join, right? So same thing as with any Hangouts or Zoom calls, that's your session. That's the room concept. Room have participants. So when participants add, remove, or modify tracks or join the room, all the other participants in the room will be notified of that and can react to that and do something in response. I've just mentioned tracks, which are the 3rd big primitive. So tracks are streams of video or audio, but they can also be custom data. So the mirror image of that in WebRTC, if you look under the hood, you can have the exact same three concepts, the data streams are open-ended. So if you use raw WebRTC and something we did for the Bell project, we were controlling the little cars by just opening up a data socket and sending UDP messages saying, effectively where the controls were on the controller device. And so that allows you, that channel, to do effectively anything you want, and you can open up as many as you want. So that makes the solution, very versatile, the library very versatile. All right, so we're going to get started on actual live streaming setup. So here we're looking at installing the actual LiveKit server on your machine. So it's fairly straightforward. You just run these little commands. Now, if you try to run the LiveKit server just like that, you're going to run into a bit of a problem. You need to have proper keys and a proper setup because you might want to run into production mode, which is not what we want to do today. So we're just going to run it in dev. As you can see, when you run a dev server, it just generates these little mock keys for you. And here we basically see a server that would be up and running. Now, before I go any further, there's another little wrinkle that I want to mention, is the authentication part of things. So once you have a LiveKit server, you need to be able to mint tokens so that participants can actually join that server in a secure way. So that's not something that comes necessarily out of the box. They have plenty of samples, and we'll see today we're working with one of those samples to generate these auth tokens. But it's important to understand that without an auth service that can sort of verify that your clients trying to connect to your session are who they are, then you couldn't really operate, right? So auth service will be whatever you want. It could be backed by Firebase, you could have your own system, whatever it is. The auth service mints a token, says this user has the rights to do the following things in this room for this amount of time. And that token is passed on to your user, and with that token, they can operate and talk directly to the LiveKit server as so. The LiveKit server is the one offering services like creating rooms, creating tracks, adding participants. If you have the right kind of token with the right permissions, you can create brand new rooms, as you might imagine, and all of that. Right, so keeping that in mind for the rest of the exercise, because that's kind of important. So for the live streaming example I'm going to show you today, which is you can find this code on the LiveKit servers right there. You can see that you can see the GitHub address is there. There's other slides giving you all those details, so don't worry if it's a bit small for you right now. But right now I just wanted to express the idea that to run the live stream example, all you need to really do is to edit the environment development keys, as you can see on the screen right there in the last line. And once you have that, you'll be able to effectively start and run your own server. So I'll get back to exactly what goes on with that live stream server. But right now what I'm going to do is first off show you this slide. It's coming back a bit later, but if you want to have all the details, all the references, and there's a specific repo I've built for today containing the Android app I'll be showing you in a minute. So take a good shot of that, a screenshot of that. You should have everything you need, right? So at this point, what I would like to do is stop the presentation, and I'm gonna ask you to be patient with me in the sense that I believe everything is gonna work out fine. But I found out that, as one does, that the network at the conference is not necessarily always very conducive to what I'm trying to do. So I'm running my own little Wi-Fi network right now to try to show you how these things all work. So the first thing I wanted to do today is to show you that, no jokes, running and starting up your own LiveKit instances is actually pretty straightforward. Right now I'm killing the ones I have running right now, taking a little risk, restarting everything fresh. So hopefully that'll go well. But effectively, once you've installed, if you're on Mac with brew LiveKit, the only command you need to do to run the actual LiveKit server is as follows: LiveKit server dev. The bind 000 here is to allow me to hopefully connect the Android app a bit later to the server. It needs to sort of be able to answer to other IP addresses. So if you're running in your own home environment and want to connect over your LAN between devices, that you're going to have to use that bind flag. All right, so we just started a LiveKit instance. And next to that, I have the project checked out for the actual live stream example. So this is a combination auth server and web server, as I'll show a bit later in the presentation with a nice little slide. But right now, what we're going to do is just run our npm command. And of course, when I'm on stage, my brain goes to, my brain freezes. I forget all the commands. So thankfully, I have a history running here. Cool. So we have everything running. So I'm going to use a little command click shortcut. Actually, no, I'm not going to do that. I'm going to jump to my browsers that were pre-prepared here. And I'm going to restart the example from scratch. So once you have this running, what you can do is navigate over to localhost 3000. And it's going to happen in a second. Okay, so I have two browsers here. I'm going to just show you like two browsers talking to one another. Spoilers. So if you stream from your browser right there, it's going to hit reload because I tested it earlier. It needs to be in a fresh state of mind. So here I'm going to be the host. As you can see, you can enable chat, you can have viewers participate. The chat feature is something that comes also with LiveKit. So you have like affordances in the library to allow messages to pass back and forth between different users on top of the data channels I was talking a bit earlier. So that's quite practical and quite neat. All right, cool. So I'm here, right? That's working. So I don't have to see my ugly mug on camera all the time because it distracts me. I've used something called OBS to help me manage the streams that I'm showing today. OBS can create a virtual camera on your Mac that you can connect to as if it was another camera, like your actual webcam. If you're not familiar with it, it's quite a practical program. I really suggest you check it out. You can effectively grab different video streams. You can do a lot of fancy stuff with OBS. Right now, I'm just going to show like this little timecode screen for now, nothing fancy. I have other uses for this a bit later on. All right, now at this point, I just want to show off how to join a stream. And as you might expect, it's pretty simple. You do need to know the name of the room. So what's happening here is we're talking to the live stream app. It's creating those tokens. Those sessions are getting initialized. We're naming ourselves, and we're going to join the stream, and there we go. So main thing is you can say hi, the chat works. And in these examples, they have like, you know, little cutesy things like that. So anyway, that's fun. So that's how to set up your live streaming server. Cool, so let's get back to this presentation. Actually, if you give me a second, I'm gonna flip back to separate displays, and there we go. All right, how am I on time? 17 minutes, all right, so I'm gonna try to not bore you too long with the code that's coming up. So, all right, we're going to look at the Android apps. So today, part of today's schedule, the promise is we will build a live streaming app. Now, when you build a live streaming app, I recommend that you check out my repo of the code. I went through LiveKit's samples, and why I am extremely impressed with the quality of the code on every level. The Android app, maybe that's because I'm an Android developer and been doing it for a while, you know, did not fit my very exacting needs. Effectively, all it was is that the versioning of the different libraries used in this app were a bit off. And I found a few glitches, which I've solved so that you could, you know, get like a nice experience if you want to try it out. I'm hoping to upstream these changes to the main repo, but that's been so busy with preparing for today that that's not been sort of on my radar much. But yeah, so the first thing you need to sort of keep in mind is the navigation graph for this application, this kind of application. It is kind of intricate and involved. But effectively, you can see here there's like two groupings. The first one is simply logging on, entering your credentials and all that, the room you want to log in. And once you've started a session and you've entered a room, you get bottom sheets that open up to allow you to look at the other participants, ask to become a streamer on the stream, or mute somebody, things like that. And you also have like a little screen that shows you what is the actual name of the room that you're in, which is like kind of important if you're using the auto-generated names and things like that. All right, so at this point I'm going to be very terse on the code examples and just try to give you the general gist of things because, you know, let's face it, looking at code slides usually puts everybody asleep. But there's like big concepts I kind of want to take you away. When you leave this room and you look at the code, you'll be able to sort of go, okay, I get the structure of the app. So first thing to notice is that, with just 4 states, that's how we can start a session. Fairly straightforward stuff. So you need a username, you need to know if you want to enable the chat, user join stage, camera orientation, all these nice things. Then once you've got that all set up and you say, okay, cool, I want to start a live stream, at this point you can enter all that data in this little screen. So that's my cat, proud daddy here. So once you have that set up, you need to start thinking about building the request to start the new stream with the auth service, right? So that you need to connect to the live stream server and not the live kit server. The live stream server is our minter of tokens right here. So this is what the query looks like. This uses retrofit, regular retrofit. So as you see, it's nothing super fancy. We're just passing the parameters that we defined a bit earlier. And after that, once we get a positive response, if everything is set up properly, which we'll check in a minute, we'll have the auth token, as you can see right at the top in the connected session right there. I'm just going to bring my little tablet up because I find that, when you do codes, it's kind of important to sort of highlight what you're talking about. That kind of helps. Cool. So the response auth token is really like the big thing here that you want to take notice. That connection details are obviously also important, but we can sort of gloss over them right now. So the live stream API is in 2 parts. So I've talked about how to mint coins and all that. At the very beginning, the live stream service itself offers a creation of stream or a joining of stream service, fairly straightforward stuff. And as a second stage of kinds, it offers you an authentication API for the people that join the stream. So if you think of people that you might want to invite to the stage so that they can participate on the call, or you want to remove from the stage because they're just being too noisy or something, this is the retrofit API that you will be using. Now, I've just put up that diagram because if it's not clear yet, the service that we just started, that NPM service, live stream service, is actually playing 3 different roles, right? It's minting the auth tokens. It's offering a specific API for live streaming, which might change if you're creating different types of rooms, right? If you're creating a, say, remote control race car app, then you would create most likely a very different type of API. And then the third thing it's doing in this specific case, it's actually hosting the web app, as you can see in the top right. Once the clients have gotten what they need from the auth and livestream backend, they're just going to communicate with the LiveKit server directly to handle like joining rooms, adding, listening to participants, muting streams, and things like that. Cool. So we're successfully authenticated. The cat's gone. It's kind of sad. Right. So once we're successfully instantiated and connected, we enter in the code. You're going to see that there's something called room scope. So I'm not going into the details here too much, but room scope in Compose, right? Because this is a Compose API. It's funny, I don't even feel like I need to mention this is a Compose API because that's just how it is nowadays. Hopefully you're not stuck on XML. They do have an API for that too, but probably not the best kept up. So anyway, the room scope, the idea is that when you use that in your composable, it opens up access to every LiveKit state so that you can actually work with it to connect to video and show different screens. So the idea there also is that that's how you're going to sort of handle your on-connected and your on-disconnected type scenarios, right? So if you want to react to a connection or disconnection, be it only to show a little pop-up that says, hey, we're connected and all that, that's where you'd be doing it. Then once you're in the room scope, everything else that gets called, all the composable down the tree will have access to the LiveKit API initialized session, initialized room. And so that's the screen that we'd be seeing once we're connected, right? We just jumped from the connection screen to the actual streaming screen, the room screen it's called in the application. And so once we sort of go through the room nav host and set things up, as we're setting up the navigation, every single composable being built here has access again to the LiveKit APIs. And so you can see stuff like here, at that point you can start accessing like, the different tracks, You can decide to look at the different participants that are sort of in the call. You can react to these things. You can set up listeners, all that good stuff. Ah, she's back. Quite happy. So, isn't she the cutest? I call her Her Majesty the Preen. She purrs a lot. Anyway, sorry. I'm quite proud of my cat. Right, so at this point, you can see that you have access to all this metadata and you can do all these nice things. Now, once you look at the code, you'll realize that one of the next big things being set up is this participant grid. And if you've been on a Zoom call, you know that whenever there's more than 2 people, 3 people, 4 people on a call, you need to sort of manage how to display all that. And that brings a lot of complexity to the app, frankly, which is not something we're going to look at here. All you really care about, right, is showing a video feed. And this is done through this very simple little class, Video Track View, which LiveKit provides for you for free. That's it. Once you've set that up, effectively it's going to take care of doing the Android view, compose, interop, and do the texture view render and all that nice stuff that you would do if you've ever worked with cameras. It's all for free. That comes for free. You just put that composable there and boom, you have the video screen we're looking at right now. All right, so again, reference screen for, I don't know if we've had walk-ins while I was chatting, but yeah, cool. So I'm looking at time. I'm going to be flying through certain other things. Just again, I'm just going to go back though to this. All the stuff I'm going to be flying through in a minute, it's all in these repos. So I'm hoping that you go visit, give me a star, and I'll get a lot of stars in my GitHub repos. So if you do actually try to use it, follow up. This is one of those repos that I'm working actively on and hoping to share back with everybody all the results of my little experiments. All right, so one part of this presentation I did want to touch on is some of the WebRTC details, because has anybody ever worked with WebRTC in the room here a little bit? So for all the other ones, you're the lucky ones. These are the people that suffered, because it is actually, well, I wouldn't say it was that bad, but it is not necessarily a simple thing to work with, right? So LiveKit, what's interesting to keep up the performance is that it's using like 3-4 different approaches in order of priority. So the thing is that this stuff is probably like absolutely garbage looking for you if you're not into WebRTC. So I will define a few terms that are kind of useful if you're going to start playing in that space so that you understand what's going on under the hood without necessarily having to understand the nitty-gritty of how to set that up. So one of the terms that comes back a lot is ICE. It's the Interactive Connectivity Establishment. That's what's used to, when 2 devices are trying to set up the connection, 2 peers, we're not even talking about all the peers involved in the normal video call, but when peer A tries to talk to peer B, it needs to effectively be able to say, wait, what's my IP on the internet, right? So it needs to talk to a stun server. It's going to need to use ICE to communicate that information to its other peer, and it's going to use a stun server to find out what its own address is to communicate it to the other peer to try to establish communication. So stun is for Session Traversal Utilities for NAT. That's a mouthful. And then the other big thing that comes back a ton is a turn server. Turn is for traversal using relays around NAT, right? That's another mouthful. The idea of turn is that if for some reason the firewall doesn't allow you to connect directly to the other peer and start exchanging streaming data, you can use turn as a middleman and send your video packets to it, and it can communicate to the other player. Right, so what does that look like if you want to put it in a bit more nicer graph, nicer context? This is how 2 peers try to connect to each other using stun, which is the fastest way possible because you don't have a man in the middle. So peer A talks to the stun server tells it, oh, this is your IP and this is your port. And then with that information, it can communicate over ICE to peer B and tell it, what those addresses are. And from the flip side, peer B is going to do the same thing with the stun server and send that information over to peer A, and hopefully a connection is established. In the case that there is a firewall, like I mentioned, then you have to use a turn server. You don't have to have a turn server to have a WebRTC connection, right? So if you're actually implementing it on your own, your first little test will probably not even have a stun server, and you're going to start swearing the second that there's a firewall between you and your other peer. So this is the gory glory of the full thing. Now, what I kind of like, one thing I didn't talk about is SDP. I'm not going to talk about it now, but That's an important little bit that you want to check later. That's how you define with the other peer, like what kind of resolution you want in streaming and all that. But the key takeaway here is that this is the literal hashtag for the documentation for the graph. So yeah, I always find that kind of funny. So anyway, LifeKit takes care of all that for you. And the thing to remember about LifeKit and its performance is to know that first it's going to try ICE over UDP to get like the best possible speed connection between two peers. Then it's going to fall back to turn with UDP when that's not possible. Then it's going to fall back to ICE over TCP when UDP is totally disabled because of firewall or networking reasons. And at the very last, it's going to try turn with TLS, you know, when you need to have encryption going and all that because your different network rules are there. So those are usually the four sort of degrading levels of quality that you're going to see in a LifeKit call, which is like, you know, there's a lot of complexity baked in there that's taken care of for you, and it's also very performance-minded, so that's the key takeaway here. All right, so I've talked about the live streaming app. Hopefully you have enough information to try it out at home. Now I'm going to talk about the machine learning part, where sort of, I have 10, 15 minutes, I'm guessing, before I have to be kicked off stage, so we're going to try to keep it short and more, you know, not too much of a deep dive into code slides. But anyway, so Python. The thing you'll notice with my examples is Python is a bit of a different deal, as in it won't need to talk to an auth server and start doing all these extra steps. And the reason for that is that you configure these agents, which are going to presumably be running on your servers, with your full keys. So they can talk to the LifeKit server and just do whatever the hell they want, effectively. So that actually makes experimenting with them a lot simpler, right? It kind of makes sense. Royalty can mint their own coins, effectively, is my joke here. All right, cool. So first example of using machine learning. Well, it's not really machine learning at this point. The first example I have, which you'll find in the repo, is all about simply pushing pixels to a video stream that you've baked yourself. So the top stream is not what we're going to be programming. What we're going to be programming today is the bottom screen with just the rotating color cycles, right? So if you go look at in deeper detail at the code I've linked, you'll see that there's a standardized way of connecting to LifeKit, right? And just opening up the room and getting in there, adding yourself as a participant. It's honestly kind of boring, and it's going to look a lot like what we just talked about earlier. So the main focus here I wanted to sort of mention to everybody is this part right there. Effectively, all the code that can manage and work with a track ends up at some point with an output source. And you can see this RTC video source is a LifeKit object that you're going to be handling with. And you can dump pixels into that output source. It's a bit of a weird name, a video source output, but that's how the APIs are built. So just really, you know, the output word is the key word here. And what you'll see is happening right here is that we're just running effectively in an infinite loop, right? We do try to sort of respect a certain frame rate. So we have to manage that, not to sort of kill our CPU, just like trying to run as many frames as we can when really at the end of the day on a call, if you go above 30, it's going to be kind of surprising. So this kind of code right there is about all this idea that we want to limit the frame per second to 30 and not do too much work. And these bits of code right there prepare the pixels, prepare the bitmaps, and you get a call like so here with the video frame to effectively just take that bitmap and push it down the track. So it's fairly straightforward. Might look a bit funky at first if you're not used to Python, but you know, not an insane amount of code to look at to start doing something interesting. Now, is this animated? Wait, sorry, I'm just going to come back. So the idea here that I wanted to sort of, not again to bug you with my mug on a huge screen, that wasn't the idea, but the concept here that we're going to work with is I'm going to show you a small function that allows you to not only output and send, you know, new drawings, but take the source image, run some inference on top of it, and then draw over it, right? That's more the kind of scenarios that you're going to probably want to be playing with. So in the samples, you're going to find this face overlay. So it's using a TensorFlow light model pre-baked that can see your face and sort of locate the eyes and all the different vertices, as you can see. And so that's right there, the face land marker function right there. It's also using a little bit of OpenCV, so you can see, so OpenCV allows you to sort of play around with the images and manipulate them. So that's oftentimes why you're going to see some OpenCV in there. Let's see. So again, we have a bit of an input stream loop. So for every frame that comes in, we run some inference. Frame comes in, we take the image, we send it to the TensorFlow model that detects the face, tells us where the eyes are, and then we have a little bit of boilerplate code that allows us to prepare that image. And once we've detected here, we've done the detection, then here we can do the drawing on top based on these detections. So it might seem overly simplistic, but at the end of the day, when you're starting to write these little agents, there's really not that much code to write. Like if you're using models that are out there and you just want to try different ideas, which is, the concept as this talk is, these tools allow us to prototype a lot of fun ideas for customers to sort of help them improve some of their own workflows, right? So you want to be able to sort of import all sorts of different models, and it's not that hard to do so with this kind of setup. And so, yeah, the other main point for this little part of it is that there's a bit of preparation code where we overlay the old image with the new data and send that over. So yeah, so that's kind of that for code for today. We're going to run through the rest of the thing. Now I'm going to more talk to you about what kind of things you can get up to, what kind of trouble you can get into if you're prototyping ideas for customers using these techniques, right? Because you might be wondering, well, that's kind of cool, but what can you actually get up to as to for useful work, right? Like that's like a fair question, I think. So so now we're going to look sort of basically at one of my favorite use cases. If you know me, I've presented about this kind of subject before. Vinyl collecting, so I'm a big vinyl collector, sort of a bit of a happy accident, but at the end of the day, I got this problem where I have enough records to open up my own online shop at this point. And keeping inventory for thousands, literally thousands of vinyl records is kind of difficult, and it's an absolute must because quite frankly, half of that is usually garbage, right? If you get them for free, there's a reason they're free. So to sort of help me along this year, it's gotten to the point where even my friends have gotten involved. And so that was just a little flyby mentioning that last year's talk. So anyway, my friends got involved and we got our kids involved, and sort of basically every kid's in our circle's summer job was to open up boxes of vinyl, take pictures of every single one of them and sort of put them back in there. And we have like this database of a couple thousands of pictures right at this point, and we're not even done scanning the whole collection. And so the idea there is that we wanted to find a way to sort of bring the inventory problem under control, but we want to sort of do it in a way that we can talk about it and show that where can innovation sort of happen. And the main idea why we want the kids to take quick pictures of everything and find out what we have is that when you actually prepare something for sale, it's a lot of work, right? So you need to take a proper product photo with the proper lighting, and you need to look at the record, kind of grade it. Is it in a good state? Oftentimes you're going to actually have to listen to it to see if it's any good, if it got scratches, and so on and so forth. So that's a lot of work, and obviously you don't want to be doing that for the kind of crap part of the collection. You just want to be finding the actual gold stars right there. That album right there is actually literally worth $162. We found one in one of those boxes. That's kind of cool, right? Anyway, but to avoid having to put in the effort to sort of start scanning everything and actually doing the full work, we came up with a few ideas that involve video streaming, and that involve recording all the work that we do, taking those pictures and sort of extracting info and just being able to sort of scan the collection. So I have to admit that in this case, we've sort of done a lot of, like, our actual work has been mostly batch jobs, not like live WebRTC calls, although that's definitely on my roadmap because I feel that just sifting through a box or even just like visiting a store somewhere that has a lot of these old records, we kind of want a tool where we can actually see right away, hey, this is a pretty good record, we should grab it. So I'm short on time. I was going to jump to Hugging Face and show you some of the different models that can do background removal. But effectively, there's quite a few models that allow you to just say, I want to remove the background, and it naturally understands that the thing that's in the main middle of the frame is the thing that's in your subject. So you run your video, your frames of video through that model, and you'll end up with only the records that you can see. And a little bit like the produce matching system I was talking about earlier, you can take that, send it into an engine, recognize the image without having all the noise around it. That actually improves the results a ton. It's also something that you can send to an LLM and say, hey, can you come up with like a description of this album? You've probably heard about it by scraping the internet, right? So LLMs are really good at generating product description. So that's like all the kind of things that you can prototype and improve a workflow for a very physical, real task, real work. If you bring that to a phone over a live streaming connection, what's interesting then is that anybody can jump on a call, an agent jumps in and starts analyzing what it sees. So you don't even need to install an app. You don't even need to sort of, get into a complicated setup, and you can work as a group on a project like that. Everybody can jump in on a call and scan at the same time and sort of share notes and communicate. So anyway, this is the part where we have like scripts that we wrote to actually do this analysis, take the pictures, write a product description up on Shopify. We have the plugins and this is something we prototyped for fun. What I'm saying is that we found that prototyping with these kind of approaches is actually something where you can come up with like a weekend project that really, kicks butt. I'm hitting my time limits here, so I'm going to keep this real short. Another concept that we've been working with a fair bit is not necessarily Lego, but Lego is more to illustrate the idea. It's more like augmented reality type of scenarios. So there's a lot of times where you're working a specific job and you would just like to be able to have a little bit of a help from an assistant. And so Legos is kind of like the conceptual idea. Lego kits nowadays are pretty sophisticated. There's like a ton of different little parts and a lot of little clever bits. So the example we give here is this idea that if you start looking at the instructions and the pieces that you have to line up and prepare for every step of these instructions, it's not necessarily that hard to come up with the idea of saying, okay, I will film this and put some models that can do some OCR, that can do some zone recognition, and that can do sort of provide help just by telling you, okay, you have so many pieces, you're looking for so many pieces of that type, of this color. Now, the thing that I do want to mention, and part of the innovation sort of concept that I think is important to share with folks, and I'm just going to skip over the code in here, but when you're talking about doing the kind of things that I'm talking about, it's very easy to oversell what's possible. Object recognition for the Lego problem I'm just showing you here is actually quite complex. So you can't possibly hope that using an OpenCV script and sort of untuned models without having like somebody really specialist in that space, you can't hope to say, okay, I know which Lego piece it is from the gazillion types of Lego pieces there are out there. What you can more easily do is isolate different blobs on an image, take those blobs individually once you've basically segmented them, and say, okay, what shape is it? Oh, it's actually more of a conic shape. That's cool. What color is it? Well, it's actually gray or blue or red, right? And if you start filtering on these kind of things using sort of more lightweight models, what the takeaway I want you to have is that you can extract a ton of value using sort of off-the-shelf machine learning components and combine this information a bit later down the line to help the customer, do their job. You don't have to be hitting like the big production models and having super fine-tuned things everywhere to bring value and quickly prototype interesting ideas. And that's it on time. Thank you very, very, very much for being here today.